So, let's continue our second topic, which is microprogramming. So, what is microprogramming and what role does it play in computer architecture? Microprogramming is a method for implementing control logic in a computer central processing unit, which is CPU. It uses a microprogram, a sequence of microinstructions to control low-level operations. Each microinstruction specifies control signals for elementary operations like data movement, arithmetic operations, and control flow management. Microprogramming simplifies control unit design and implementation, allowing for easy modification and extension of control logic. Control of instruction execution. Microprogramming controls the execution of instructions through a series of steps. Number 1, instruction fetch. The CPU fetches the next instruction to be executed from memory. Number 2, instruction decode. The instruction is decoded to determine the specific operation to be performed and the operands involved. Number 3, microinstruction sequence. Based on the decoded instruction, the control unit assesses the corresponding microinstruction sequence from the control memory. The execution. Each microinstruction in the sequence generates control signals that activate various components of the CPU to perform the required operations. And finally, completion and next instruction. Once the microinstruction sequence is completed, the CPU moves on to fetch and execute the next instruction. Advantages and disadvantages of microprogramming. So, what are the advantages of microprogramming? Number 1, it simplifies control unit design, which means the design of control set of microinstructions. In terms of flexibility and upgradability, it changes and updates the CPU's control logic, which can be made by simply modifying the microprogram without the need to redesign hardware. Number 3, it's easier to debug and testing. Microprograms can be tested and debugged more easily than hardwired control logic, leading to quicker and more reliable development. The support for complex instructions. It allows implementation of complex instruction sets such as those found in CISC, complex instruction set computing architectures, by using detailed micro-instruction sequences. What are the disadvantages? It's slower in execution speed. It requires increased memory. Also, it's complex in design, and there is potential for bugs, which means errors in microprograms can lead to incorrect operation of the CPU, requiring careful design and thorough testing. So this was for part number 2, microprogramming.